All right, folks, welcome and thank you for attending the December Safety Conference webinar presentation of 2013. My name is Katie Parrish, Editorial Director of Maximum Capacity Media, and your host for today's conference. My contact information is located at the bottom of this page and will again be available at the end of the presentation in case you have some follow-up comments, ideas, suggestions, or questions after today's event. Maximum Capacity Media would like to extend a special thank you to the sponsor for today's presentation, United Rentals. United Rentals is the largest equipment rental company in the world with an integrated network of 822 rental locations that operate in 49 states and every Canadian province. It offers for rent more than 3,000 classes of equipment. Its team of approximately 11,700 employees serves construction and industrial customers, utilities, municipalities, homeowners, and others. Learn more about United Rentals online at www.unitedrentals.com. When safety was first introduced in 2007, our mission was to bring lifting equipment users and operators presentations and information to raise safety, introduce best practices, and bring compliance awareness to the construction, rental, and industrial markets. Topics are selected to help provide clarification, unify industry efforts, and help save the lives of equipment operators and workers on the ground. Today's presentation will review key methods for using aerial work platform equipment to help the owners and users of aerial work platforms understand their responsibilities when operating, transporting, and using this equipment. The Scaffold and Access Industry Association and OSHA Alliance has released a series of tip sheets that focus on the primary techniques for using aerial work platforms. In cooperation with the SAIA/OSHA Alliance, this presentation will review key areas of these resource documents. To tell you a little bit about the Alliance, since the SAIA and OSHA Alliance was first signed in 2008, OSHA and SAIA have developed aerial lift equipment, rolling tower, transport platforms, and mass climbing work platform safety materials relating to scaffold access and fall hazards, as well as ANSI consensus standards. SAIA is a national trade organization founded in 1972 that represents the scaffold, aerial lift, and access industry. SAIA promotes safety in these areas by developing educational and training courses, audiovisual programs, and codes of safe practices. It has more than 1,000 member companies, including aerial work platform dealers, distributors, scaffold and shoring erectors and renters, plank and platform manufacturers and distributors, safety and engineering consultants, and government officials. Through the Alliance program, OSHA works with groups committed to worker safety and health to prevent workplace fatalities, injuries, and illnesses. These groups include unions, consulates, trade or professional organizations, faith and community-based organizations, businesses, and educational institutions. OSHA and the groups work together to develop compliance-assisted tools and resources, share information with workers and employers, and educate workers and employers about their rights and responsibilities. The Alliance is scheduled for a 5-year renewal signing in Washington on December 18th. All Alliance documents are available on the OSHA and SAIA websites, and I can provide that information at the end of the presentation for you all. Moving on to our presenters. Today's presenters are Jim Doris and Gary Riley. Jim Doris, CFP, is the Vice President, Health, Safety, Environment, and Sustainability for United Rentals, Inc. Jim is an accomplished business executive with more than 13 years of experience leading HSE and other related functions. Prior to starting with United Rentals, he was the Corporate Occupational Safety Director for Cummins Global Operations. Jim earned his Executive MBA from the Fogelman College of Business and Economics at the University of Memphis, as well as a Master of Science degree in Occupational Safety and Health and a Bachelor of Science degree in Biology Chemistry from Murray State University. He is a professional member and past president of the West Tennessee American Society of Safety Engineers, a member of the National Safety Council Advisory Council, and is active in community affairs by frequently volunteering his time. Gary Riley is a recognized aerial work platform expert. He has 25 years of hands-on experience related to the aerial work platform industry. His experience includes delivery, field service and maintenance, and rental and fleet and risk management and operator training. He has worked with several aerial work platform manufacturers in the area of product development. He is also involved with trade unions and organizations and setting them up to offer quality American work platform training. He previously owned and operated aerial platform and telehandler training, which is an approved AWP training center conforming to the ISO 18878 standard for mobile elevated work platform operator driver training, delivering the PAL, Powered Access license to successful trainees. He's a national requested speaker on aerial lift safe use and has previously presented at the Aerial Platform Safety Conference, Construction Safety Conference, Safe Access Fall Protection and Training Conference, Aerial Platform Council, Scaffold Industry Association, and Travelers Insurance Safety Academies. Gary is now employed by NES as an approved AWPT approved senior instructor. If you have questions for Jim or Gary during the presentation, please type them into the question box on your screen. We will answer all questions at the end of the presentation. Additionally, this presentation is being recorded and can be accessed this week on safe-tconference.com and the Maximum Capacity Media YouTube channel, as well as liftinaccess.com. I'll show addresses for both again at the end of this presentation. Now that I've completed my script, Jim, I'd like to open the floor to you to add some opening remarks.
Yeah, absolutely, Katie. Thank you. And thank you for moderating the call. Appreciate that. Also want to extend a thank you to everybody that participated and contributed to getting the webinar together for today. And a special thanks to the SAIA OSHA Alliance team that helped to develop the materials about today's topic that we're going to be covering. First, I just wanted to talk about our vision. When they came to us to sponsor a topic, I thought this was a perfect example and something that we needed to pick up and support because I view it as a form of innovation. And if you look at United Rentals' vision as a company, it's it's serving as a catalyst to drive the entire industry forward through continuous innovation. And I view this type of work as innovation. Many times people think that innovation has to be a new gadget, the iPhone 5 or the latest tablet, but innovation comes in a lot of forms. And this is a prime example and something that I felt like needed to be supported. It's something that's a collection of very good ideas with the overall objective of sending people home the way they came. And I can't think of anything better for us to get behind. So again, I appreciate the SAIA and the OSHA Alliance's work to try to elevate and improve the industry. So it's also an opportunity for us to get together collectively as manufacturers, as rental houses, as users, and others to be able to work across competitive boundaries and to take topics like this and to work collectively and share collectively to make the entire industry a safer place. So I want to thank everybody involved, and a special thanks to Gary. I'm going to turn the call over to him. I really appreciate him taking the time and the preparation to present this topic. So Gary, over to you.
Thanks, Jim and Katie, and the Safety Conference and the SIA for allowing me to present this for everyone that's on the call. Bear with me. I need to take just a few seconds to start my presentation. Am I there, Katie?
You're there.
Okay. I rearranged the topics around slightly in order because I wanted to be able to deliver the machine first to the job site. Then I wanted to go through a job site management checklist. Then I wanted to be able to do a pre-start inspection on the machine. Then we needed to go through a implementing selection process of the appropriate fall protection. And then we need to obviously have a rescue plan in place if we're using fall arrest on aerial work platforms. So bear with me. We're going to try to go through this virtual process. The first thing we need to do, and this is the first tip sheet that the SIA and the OSHA Alliance produced. I'm sorry, not the first one, but the first one that I'm going to use in this order. Is preparing self-propelled aerial work platform for transport, because we're not only operating the aerial platform, but we're also driving on regulated roads for the Department of Regulation. The first item that comes up on the tip sheet, again, that says that there's a wide range of trucks and aerial work platforms. So we need to take in consideration the operator's manual for the truck that we're using and the operator's manual for the aerial platform that we're operating. That being said, when the operator does drive the truck on and off the machine and to and from the job site, they are now operators and need to be trained as operators as per the employer's responsibility. There are different machines in different capacities, and there are different trucks that haul different weights and capacities. So we need to pay attention that we're not putting too heavy of a machine on too light of a truck. the serial number placard on the machines will give you the specific weight of the machine, so we don't put too much weight on certain trucks. And an example could be a small electric 30-foot knuckle boom on a single axle rollback. What looks smaller than the average car can actually overload the truck and cause problems when you're driving. In addition, the drivers are solely responsible for making sure the machines are properly secured per the DOT regulations and their company policy. So now that we're preparing the machine for transport, the vehicle, now that we're preparing the vehicle for transport, we need to be sure, again, that the loading surfaces aren't slippery or have oil on them. We need to make sure that we have the right rigging hardware for the machine that we're carrying. So again, we need to be cognizant of the weight of the machine that we're transporting. The transport vehicle needs to be parked on a level surface. The vehicle must be secured to prevent rolling. Whether we're loading and unloading a dock or on the ground, we need to make sure that the transport vehicle is secured from moving around while loading and unloading this dynamic movement of equipment on and off the truck. And again, the truck deck must be clean to prevent slipping and tripping hazards or traction of the machine loading and unloading. We do not want to drive the machine on a slope that exceeds the grade ability of the machine. And back in my day, we actually had machines that wouldn't drive up the slopes of the truck, so we had to use the winches. Now that we're using the winch, we need to make sure that the winch isn't incapable of pulling the weight of the aerial work platform on the truck. Nowadays, equipment can weigh in excess of 45,000 pounds. So we need to make sure that if we're loading and unloading a disabled vehicle onto a truck, that we're not overloading the winch or the winch's capability. Sometimes machines need to be loaded on trucks with forklifts, so we need to make sure that the forklift is capable of loading the machine on the truck, and we're using the appropriate fork pockets on the AWP. We're not picking the machine from the side where the fork pockets are on the end of the machine. So lots of things need to be taken into consideration just loading and unloading machines to and from trucks. We want to obviously use the lowest travel speed. A lot of AWPs have multiple travel speeds and multiple RPM selections for the engine depending on the make and model that we're loading. So we want to put it in its lowest travel speed. Once we get the machine on the truck, we want to ensure that the height of our transport isn't exceeded the height of the allowed requirement. It's always a good idea to have reminders in and out of your facilities to make sure that you haven't exceeded the transport height. Always taking the machine's center of gravity into consideration the distribution of the load. And this information is commonly found in the operations manual. We never want to use the machine elevated on a transport vehicle. I think we had a mishap in Minnesota recently. Here we have at the bottom of the page some nomenclatures for proper load securement. Again, place the machine in a fully stowed area, per the manufacturer's instructions. Some boomlets have transport pins that keep the machine from inadvertently swinging while in transport. If they have the pin, we want to put that in place to prevent turntable rotation during travel. Some machines require fall protection. We want to make sure that we have that on when we're loading and unloading, as there are additional hazards in the loading and unloading process that drivers incur when they're engaging in an act. Ensure the machine is clean and of construction and debris, because as we remove these machines from job sites, we find a lot of debris from the job sites that need to be removed before we transport them down the road to keep windows from getting knocked out and so forth. Again, we want to secure the machine according with the manufacturer's instructions, using the appropriate hardware, chain straps, or whatever we need according to the particular machine that we're transporting. And again, there are diagrams below to help you make that accomplishment. So now that we've got the machine to the job, the next tip sheet on our webinar is going to be the AWP Jobsite Checklist. This checklist is job-specific, equipment-specific, and personnel-specific. So we need to fill this out accordingly based on who we are, where we're at, and what we're doing it with. The first line item on this checklist is the operator trained. And one of the first best practices statements that came out was training and familiarization, which gives you a clear framework of what appropriate operator training should look like. So this is a good opportunity to get into this document to ensure that your operators have received appropriate training so that when we get to the job site, we don't have to figure out how to make this happen. So try to make a proactive stance in ensuring that your operators have been appropriately trained by taking a look at this best practice document that's available from the SAIA's website and other various associations and organizations. So let's assume in this virtual website the operator is appropriately trained. We can check that box. The next item is when the lift platform, will the lift platform reach the work area? And this can be part of a pre-job assessment, which the user has a responsibility to do a workplace inspection, so we may want to do this before the machine shows up. In this particular, I'm going to show a picture of a machine that won't reach the work height. Now, they could have changed their idea of what they wanted to do later, and the height may have been good enough or sufficient to work on the sign, but now they're going up higher. So the job changed during the action of doing their work. So they needed to get obviously a taller machine. So let's go back to this, and I'm going to put a big no there because they don't need to be doing that. I'm going to say no, the lift is too short and they need to have a taller lift if they want to go and do that secondary work. And I'll get back to the too short of lift in a few moments. So the next thing is surface and soil conditions that the lift will be operated. The operator is responsible for all supporting conditions and all operating configurations imposed by the aerial platform. And to try to clarify that, in the operator's manual, you'll have information that will give you the overall occupied pressure and concentrated pressure, and sometimes listed in best and worst case, depending on the load distribution, the placement of the boom, and so forth and so on. And you need to understand this information and compare it to whether or not the ground will support it. There are also different classifications of soil that we need to take into consideration because we may need to put additional outrigger mats underneath the machine to divide the concentrated pressure over a larger area, depending on the best case, worst case concentrated pressure and the soil that the machine's on. Let's say on our virtual job site that we're okay, so I'm going to put a non-applicable there. The next thing is pedestrian traffic, where the machines will be operated. We need to establish work zones to keep personnel out of our work area, especially when we have pedestrian traffic or even personnel that are in the same working environment. We need to keep them clear of the area because they have no stand against a moving platform. And I believe we did have a collision with an individual in another country a few years ago. So I'm going to say in this virtual website, not applicable. We've done that. We don't have that. That hazard doesn't exist. Now we have public roadways. We want to make sure that we have spotters if we have transportation going in and out. We want to make sure that the tail swing of the machine can't get into the traffic area and have our cordoned area properly to accommodate for the tail swing of the machine if we're going to be working off to the side. This virtual website, I'm going to say we don't have that. Precautions for other moving equipment. Again, we can work these machines, whether it's rough terrain forklifts, industrial forklifts, trash buggies, and all kinds of ground-based industrial moving vehicles that we need to make preparations for to ensure that we don't have a collision with the aerial platform. We can have narrow restricted aisles that cause industrial manufacturing facilities to want to continue operations where there's maybe they're going up to work on a light bulb or something, and there's not enough room for the industrial forklift to get through. We need to take additional precaution through the funneling effect where the lift may be operated in narrow aisleways. So I'm going to say not applicable on that one too. So ramps and other slope surfaces that could affect the stability of the machine. We need to look into the operations manual to see what maximum incline the machine can be operated on for our slopes, grades, traction, or gradability. This information, again, can be achieved in the operations manual or acquired in the operations manual. Virtual website purposes, I'm going to say we don't have that hazard. Drop-offs or holes, including those concealed by water, ice, mud, part of the workplace inspection criteria as outlined in the ANSI standards. I'm going to say for this particular exercise, I'm going to show a picture of an inspection cover in a railroad switching unit that had gravel over it that was difficult to see. The operator would have needed to inspect the work site prior to traveling the equipment. And as the phrase goes, these boots are made for walking. So we need to get out there and use these boots to find these hazards before we drive the aerial platform into these drop-offs. So not only is the workplace inspection to be done prior to the work commencing, but it's also during work because it's, as ANSI stated, before and during use. So we would have identified this hole prior to operating the machine. And I'm going to say now we have a hazard, we have a service cover, the hazard is the hole, the risk is the machine could tip over or potentially cause ejection. So we need to mark and avoid that hole. But we also need to pay attention throughout the usage of the platform that now that we've marked that hole, we need to make sure that we don't drive into it. Again, the ongoing workplace inspection. So I'm going to say again, we have a hazard and we need to manage that hazard. The next one, we have debris, house, and housekeeping. We need to pick up debris, not only on the floor where the platform is to be used, but also in the platform itself. We don't want to drive over the debris because it could cause instability of the machine, and debris inside the platform could lead to slipping or tripping hazards inside. But for this virtual website, we don't have that hazard, or we've taken care of it. Bumps or floor obstructions, again, similar to debris, which could cause instability. There may be slight variations in the concrete floor that we need to look at before we operate the aerial platform, because we don't want to accidentally drive into these, as the level or sight from the elevated position may be hard to see variations in the floor. For this job site, we don't have that, and I'm going to put a non-applicable. Overhead obstructions and crushing hazards. If we're working indoors, and let's just say for this inspection, we're working in confined overhead spaces. We're not just working on a low-hanging fixture change in a light bulb, but we're working up in a mechanical area where there's lots of things that could cause harm to our employees. So in this particular case, I'm going to say we do have a hazard, and our hazard's crushing. So we need to have a hard hat on for overhead obstructions, continuous observation, additional precautions such as looking out for overhead, say taking your hands off the guardrails and putting them inside to keep them out of the pinching points. We also need to have correct movement and selection of controls. We would want to drive the machine into position first, rotate it into position, telescope it into position, and then use our fine-tune movements such as jib or basket level to reach our final destination, and do everything in the exact opposite order when coming back out of those confined overhead spaces to control the movement of the machine when you're in those confined areas. So I'm going to say we do have a hazard, and we need to consistently manage it through continuous observation. And the other thing we want to look out for is electrocution hazards. We want to stay 20 feet away or notify the power company to turn the power off. Because electrocutions are definitely a hazard we need to stay and look out for. A few months ago, we had a overhead hazard. They were working in an an apartment complex. And it's not like the power lines surfaced overnight. They had been there through the duration of the project. All the operator needed to do was just simply to look up before he elevated the machine. He didn't notice they were there. Bear with me, I clicked incorrectly. So I'm going to say non-applicable for this particular virtual website. We also need to look out for wind and weather conditions or environmental issues. Rain is a hazard, lightning is a hazard, frozen ground is a hazard where the sun warms up the frozen ground, changes the ground's ability to withstand the load forces imposed by the aerial platform. So we have temperature changes can create additional hazards that we need to look out for. So it's not just wind that we're looking into, it's also weather conditions and how it affects the operation of the machine, the comfortability of the operator, and the ground that the machine is supported on. So I'm going to say in this particular case we don't have that environmental issue. We will have to be working on concrete indoors. Closed environments in other areas where insufficient ventilation exists. So if we're using a machine indoors, we want to make sure that we're using an electric machine. In highly populated areas, we may be using a combustible machine, but we might want to put a scrubber on it to reduce the carbon footprint of that machine. So I'm going to say we're using an electric machine indoors for this exercise. Another possible unsafe conditions, because it's not an exhaustive list. It's another line item in the inspection criteria for ANSI. Other possible unsafe conditions could be poor lighting, because if I have poor lighting in the environment that I'm working in, it's more difficult for me to identify and address these hazards. But we'll say that doesn't exist now, so I'm going to put non-applicable there. So here we have a virtual website that we've gone through. We've addressed certain hazards. Also, I'm going to say we're going to go back and get a taller lift to do that next job. So this gives us a good idea and a good benchmark to follow through to consistently manage the hazards associated with the operation of aerial equipment on various job sites. And it's not even an exhaustive list. There are many numerous hazards that aren't named in here that you need to pay attention to. This is only the first page of this checklist. On the second page of the checklist, you'll have the same criteria that exist on the checklist, but some of the things that we want to look for and some of the things that I've talked about in this presentation on page 2 and page 3. And again, these are free to download off of the OSHA Alliance SAIA's website. And if anyone wants to, Katie, I'm sure we'll be happy to email them to everyone. And again, there's a statement of best practices, which is also downloadable, which gives you a more fundamental approach to the appropriate equipment selection and a risk assessment of the work area, which is also downloadable from the SAIA's website and other industry organizations and associations. So now that we've managed the risks and hazards on our job site, we now need to do an inspection of the machine that we're using. And in this virtual checklist, there may be different machines that I'm talking about at different times. But again, this checklist needs to be machine-specific, location-specific, and personnel-specific. So we fill in our appropriate information. Now we're going to date our checklist to, let's say we're going to do our inspection today, 12/12/2013. The first line item on the checklist is the operator train. And as we discovered earlier, we have a barometer of information that we can use to reflect on whether or not our operators have received appropriate training. For this exercise, we're going to say yes. In addition, through a proper work assessment of the job site, the tasks and hazards that we're going to put our employees in, we may need additional personal protective equipment. So we need to make sure that if we need it, we have it on hand. Now that we have it, we need to inspect it. So if we're wearing a harness and a lanyard and so forth, we need to have our operators do these proper inspections. And are they trained to do those inspections? I'll get into some of that detail later. Another item on our inspection checklist is the manufacturer's operating manual and ANSI manual present. It's part of a requirement in the standard for a daily inspection of the machine. I'm going to put non-applicable on the deck extension because this particular machine is a boom lift. But if the machine were to be equipped with one, it also has guardrails and anchor points depending on the maker manufacturer, multiple locking points. So we want to make sure all the locking points work. The deck doesn't fall off on accident because occasionally they do because people take the decks off for different reasons and forget to put these hardware pieces back in place. So it's part of our pre-start inspection. If the machine does have a deck, we want to ensure that it's working properly, that there's no debris in the way, and this deck works smoothly and comfortably, and all the locking devices work. The machines have guardrails, gates, and chains. We want to make sure that the gate closes properly, the gate latches properly. If it has a drop-down bar, there's no tape wrapped around it or a wire tie. That's part of our mid-rail guardrail system and part of our pre-start inspection. We need to make sure that that's in place, not tied back or have been tampered with by an operator. Again, we need to make sure that the labels, placards, and control markings are legible. They give us vital information about the machine and about the hazards associated with operating that machine. We need to make sure that they're legible and on the machine. I'm sorry, I clicked too early. The next one would be cables, wiring harnesses, and hydraulic hoses. We want to make sure the cables aren't damaged or exposing conductors. We want to make sure that the wiring harnesses aren't conducting heat from lack of battery maintenance and being used under high amperage conditions, which could lead to a potential fire hazard. And the hydraulic hoses aren't frayed, chafing, showing the wire braid or the fiber core that contains the hydraulic pressure. We want to ensure that the tires and wheels are properly attached to the machine, that the lugs are tight, the rims aren't damaged, cracked, or distorted, that the tire can maintain the machine stability. We want to ensure, so I'm going to put a check there. We want to make sure that there are no loose or missing parts, such as loose guardrail bolts, missing pins that hold the fold-down guardrails in place. Again, loose fasteners on the wheels or lugs. So again, these are items that could be found all over the machine, loose or missing items. We want to make sure that the machine has appropriate hydraulic level in it. And different machines are checked in different conditions, but generally speaking, the hydraulic oil needs to be checked with the platform fully stowed, or the boom fully lowered, and any outriggers or stabilizers or other devices are fully retracted. Otherwise, you may assess the oil level being low and accidentally overfill it. Now, there's another page on this checklist, page 2, so it has more criteria, but the same date. So again, we want to make sure the fuel level is full to top because we want to make sure we have enough fuel to operate the machine throughout the duration because we need to rely on the engine to lower us to the ground. We need to make sure that the engine oil is at its proper level, that the belts are in good condition because the belt runs the alternator on some machines, which charges the battery. The battery is something that we may need to have in part of an emergency rescue or a ground rescue if something goes wrong with the machine. And again, all hoses are in good shape. We want to test the auxiliary and emergency lowering the descent devices, which vary from machine to machine to machine. So we need to make sure, one, that the operator is not only trained, but familiarized with these control functions and safety devices on the specific machine that is using at this time. That way they know how to operate them and where they are. That way they can inspect them. In this particular next is welds, banjo bolts, and fasteners. So here we have a cracked weld. If everyone can see this, this was not caught by an operator because they weren't doing their daily inspections. The next photograph shows a banjo bolt missing where the lift cylinder pin is starting to work its way out. I'll click to these a little slowly so they can upload. Mine shows 2%. The next picture shows a retainer came loose and another lift pin is walking out. So again, I didn't want to have this virtual job site inspection of the machine where everything is flawless and happy, because we have these problems that occur routinely on job sites where the operators don't identify these problems because they don't understand them, and they keep using the machines in unsafe operating configurations. So in this particular check, I'm going to put a no there because we have a cracked weld, we have a loose banjo bolt, and we have a pin and retainer that's working its way out. Next item is batteries and chargers. We need to make sure that the batteries are properly maintained, especially on electric machines. Batteries are the heart of an electric machine, and improper battery maintenance can lead to potential battery explosion, high amperage, which I talked about earlier with the cables, and the electric motor that drives the machine can eventually overheat and potentially create a fire hazard if the machine is operated on sustained low voltage due to battery maintenance or due to lack of battery maintenance over a sustained period of time. So batteries are a very important maintenance item. So I'm going to say on this particular virtual checklist that we're using a boom lift and it doesn't have the battery. But even that being said, the battery on a boom lift is also part of my auxiliary feature on some machines. So the battery needs to be free of any leaks, free of any damage, and free of any corrosion. The machine needs to have an annual inspection. Most machines and most rental companies provide the annual inspection in the form of a decal, generally around the lower control area. We'll say that this machine has received an annual inspection yesterday on 12/11 of 2013. One of the reasons to validate the machine has had an annual inspection is an annual inspection is much more comprehensive than a daily inspection required to be done by the operators and goes into much more depth and detail to, again, one of the items to ensure that the machine has any manufacturer safety bulletins done to it that may be pertinent to that particular serial number or range of machines. So we have a responsibility as a user to ensure that the machine has had an annual inspection. So I'm going to say yes, it's had one. The next item is a tilt or motion alarm. Some machines have all motion alarms. Some machines have descent alarms. So it depends on what the machine is equipped with as to what you need to test. But if it's on the machine, it needs to be working, especially when you're working around pedestrians. In addition, there's a tilt alarm. Some tilt alarms are integrated into the intellectual properties of the machine. Some tilt alarms you have access to from the ground controls. And depending on the machine, the make and model, you need to go and look at the manufacturer's operating manual for their procedures on how to test these particular safety devices. I'm going to say this one works properly, so we're going to put a check there. We need to operate and test all ground control functions, which could include a different area of the manual lowering controls. So we need to be familiar with these machines in order to test all these devices. I'm going to say that we've done that and they work properly. We also need to operate and test all platform control functions. Now we have, some machines have auxiliary power in the platform controls. Some machines have fuel selector only in the platform controls. Again, the need for familiarization from machine to machine to machine, because even though all machines are designed in accordance to the standards, they all operate uniquely different because they're designed for different purposes. So we need to inspect all these items. In addition, we have high-low elevate cutback speeds. Some machines only have one safety switch. Some machines have 2, 3, and 4, depending on the make and model. So if we have 3 elevate drive cutback switches, we need to test all 3 elevate drive cutback switches. Some machines have a drive enable feature on them so that when the boom is rotated, the drive feature is disabled, having the operator, negating the operator to, creating the operator to look at the control function arrows on the base of the machine. So at this point, I like to say that that particular machine doesn't drive in forward or it doesn't drive in reverse. It only drives in the direction of the colored arrows. And when the boom is elevated and rotated, the driver can be disorientated. So some manufacturers cut out drive, allowing the operator to look at the directional arrows before holding the drive enable feature, giving him the opportunity to travel in the direction he desires. But that's a safety device, so we want to make sure that it's working properly in this particular case. I'm going to put a check there because it is. Outriggers or other stability enhancing means. Some machines have outriggers. Some machines have axle tubes that extend. They're going to have interlocks or some type of limit switch or device in it that won't allow the machine to go up past certain height or certain range of motion. If they're equipped on it, we need to test them, and the proper procedure for testing them is in the operations manual or from the familiarization that you would have been given to upon delivery of the machine. Some machines back to stability enhancing means have working envelopes. If the machine has a working envelope, we need to understand that it has one and test it accordingly. We have another item here called checking the tower boom and tower boom telescope sequence. On certain articulating models, the lower boom telescopes. And if it does, the telescope feature will be deactivated if the boom is fully lowered. And if the boom is elevated fully and the tower is extended, the boom will not lower, keeping the machine inside its range of stability. So this is, again, another safety device specific to a particular model of machine. If it's equipped, we need to test this by ensuring the tower won't telescope when it's lowered, and the boom won't lower if the tower's telescoped. So I'm going to put non-applicable there. Then the next item up bar is the next service due. Since we're doing a daily inspection, the machine's had a frequent inspection. I'm going to say that the next service due, machines had an annual inspection. I'm going to say that the next service due is now a frequent inspection. And if you're the owner of the machine, you have a responsibility to do a frequent inspection every 150 hours or 90 days, whichever comes first. So based on the hour meter upon receiving the machine, I'm going to say that the next service is due at 2,684 hours, or March 14th, whichever one comes first. That would be the next service due. So in this particular machine, in this virtual inspection, I'm going to say that we have a broken weld or a banjo bolt missing, or lifting structure and pin retainer missing, causing the pin to work out. So we would need to report these problems or malfunctions to our supervisor, and any problems or malfunctions that affect the safety of the machine need to be corrected before the machine can be placed back into service. And then again, we have a place for a signature, again, specific to the individual and the date that it was done. Now let's move on to this inspection and say that there was nothing wrong with it, and there were no defects. There were no pins missing, no banjo bolts missing, and so forth and so on. Now, the next day, we need to do another daily inspection. We would need to do either on the second shift, as Angie says, at the beginning of each day or each shift, the aerial platform shall be given a visual inspection and function test. So on tomorrow morning, if it's the next day, we need to do another inspection of the same machine, even though we inspected it the day before. So now that we have a machine that was delivered safely, a job site that has some hazards but we're managing them, and a machine that we did an inspection in its past, we now have a safe machine and a safe work site. Now we need to look into the appropriate selection of fall protection. So there's two documents created on the OSHA Alliance tip sheet for selecting and implementing a fall protection system. Here's page 1, and here is page 2. I'm going to try to break these pages down based on the upload speed that I had, kind of slowly. So here's page 1. Here's the beginning of page 1. So the principal fall protection for the aerial platform is the guardrails. But additional fall protection when necessary, or it may be required by the manufacturer, we need to look at how we need to achieve this based on what machine we're using, where we're using it, and how we're using it. Under the OSHA regulation 1926-502, it requires that any anchor point shall be rigged to limit 6-foot free fall or less, nor make contact with any lower level. So we need to constantly keep this in mind when we're selecting our fall protection for the machine that we're using. And anytime we look at fall protection, we want to keep it in mind that we want to use restraint more than we want to try to go to an arrest system. So again, the fall protection system that we're using must be assessed by a qualified person, and they need to identify the hazards identify the hazards before they select appropriate fall protection. And again, these provisions set forth the OSHA regulations only establish the minimum level of safe use. Then we need to look at the implementation of the fall protection system with two components: identification of the hazards and the appropriate fall protection measures. Second is to implement the implementation of these fall protection measures. Next, we go on to the fall protection measures should take into account the following. Again, the primary fall protection are the guardrails, and they need to be properly inspected, which we did in our workplace inspection. Fall arrest, again, should be used as a last resort, and the objective should be to achieve fall restraint. Again, the fall hazard should be identified by, again, a qualified person, and the hazard should be properly abated. Lower down on the tip sheet, we have a couple of hazards and the risk associated with them. So climbing, one of the risks, the hazards, we climbing on the platform or mid-rail because we didn't select the appropriate machine from the beginning. We have a potential risk of loss of balance, and the control measure would be to effectively train the operator and use fall restraint to keep them in the machine. So again, this is not an exhaustive list. For a more comprehensive on the appropriate fall protection select, I'll show the document at the end as the best practices for the appropriate fall protection selection. Again, questions to ask in selecting an appropriate system would be, did you perform a risk assessment based on the task to be performed? And the qualified person was the person who did the risk assessment, the qualified person to do that assessment. Have you assessed the attachment point locations? Because they vary from machine to machine, from manufacturer to manufacturer. Some are around the toe board, some are around the mid-rail, some are at the entry of the platform, some are closer to the guardrail of the machine. So based on the anchor point location, it may change the selection or election of system that you use. Do you have a rescue plan in place? If you're using fall arrest, you have a requirement to have a written rescue plan. Have you determined the free fall distance and the total fall distance as based on the anchor point location? Are there any additional manufacturer's requirements or limitations that the manufacturer of the fall protection system may put in place? How do you avoid swing falls if you're using certain types of fall arrest systems? Will there be a change in the circumstance that you need to readdress based on the task or the work that the operator is engaged upon? And the implementation measures should also take into account the following. What is the, since some of these are somewhat redundant, but what is the fall distance from the anchorage point to the lower level? If I'm driving the machine, the anchor point is closer to the ground level if I'm driving in a stowed position versus being in an elevated position where now the floor is significantly farther away. Who and how many people are exposed to the hazards? Is there sufficient amount of anchorage for the personnel who are exposed? Will the manufacturer allow more than allow the amount of occupants so they need to have fall protection on? Some booms only allow 2 occupants. Some may allow 3 occupants, but that depends on the maker, manufacturer, design of the machine. Is the arresting force 1,800 pounds or less? Will the system bring an employee to a complete stop? Bear with me, I have something in the way. Will the system bring a falling employee to a complete stop and limit the deceleration travel to 3.5 feet? How will the operator or occupants be promptly rescued? We need to look into a rescue plan. I'll get into that shortly. Has the operator or occupant been trained in self-rescue techniques? Has the operator been trained in the proper use and inspection of his harnesses? Are there circumstances which may prompt additional investigation into what type of system we may need if he's involved in different worksite applications? Then we move further into the document. I'm sorry, that would be the end of it. So again, there's a more comprehensive approach to what systems the industry says can be used in aerial work platforms, because more than one system may be appropriate for your application. So this, again, is a document that's a free download from the SAIA or other industry-associated organizations that will give you a more comprehensive approach to what system you may want to use in your application. Now we need to look at rescue plans. Again, regulated by 502, if we're wearing follow at rest, we need to have a rescue plan in place. And here's a 2-page document that goes over a rescue plan. And I'm going to try, and I don't know if it's upload. I have 98%, so I'm going to go ahead and say, let's kind of drill down to this document. Why are rescue plans important? Because if the operator is wearing a full body harness, he may be involved in suspended trauma. And based on the weight, the health, the age, and the size of the individual, you may have a limited or longer amount of time to where you may need to make a rescue. So we need to have contingencies in place. There are 3 different types of rescues that we need to think about. One would be self-rescue, the other would be assisted rescue, and the other would be professional rescue. We need to take these into considerations throughout the use of these products in the market. So here's a typical content of a rescue plan. Again, company, site name, site specific, site of location. So it's name, project, and site specific. Have the fall hazards been identified of all existing fall hazards on the work site? So what am I doing and what are the hazards that my employees are exposed to? Detailed procedures and implementations of these hazards The assembly and inspection, use, and maintenance for dismantling and putting together the fall protection. How does the guy put it on? How does he inspect it? And the clearance distance, based on the assessment of what type of, again, fall protection you're using, the anchor point location. Have these clearance issues been discussed? And options for rescue. Again, we just talked about that a couple seconds ago for self-rescue, assisted rescue, professional rescue. So the first one is ground controls. That could be an assisted rescue because if the operator may not have fallen out of the platform, but he may have gotten incapacitated or some way. So we need ground personnel that are available to lower the machine. In addition, in case some machines are inoperable from the ground controls, and therefore the operator, the ground control person would also need to be trained on how to use the manual, auxiliary, or lowering control systems, which I go back to a part of our pre-start inspection in the earlier process. So we may have a second AWP that we want to do an air-to-air transfer if the AWP is inoperable for any reason. We may have other different types of lifts on job sites that we may want to use as part of our assisted rescue. In the wind power industry, we use repel systems to rescue the operators due to the height that the machines are involved in. And then they need to have special training for those types of rescues. And then, again, it's self-rescue, such as operating the machine from the auxiliary controls from the basket. If the machine just becomes inoperable, runs out of fuel, the belt breaks, the battery goes dead, whatever the case may be, engine failure. Or if the operator does become ejected out of the platform for any reason, there are some fall protection manufacturers that give you the ability to self-rescue with the ladder that's equipped with the fall protection. So there are many types of self-rescue that we can get involved in. And if the worker is suspended, we have to take into consideration how to deal with that. So if we have suspended trauma, we have steps that we need to go to correctly put that we need to be trained in on how to engage in rescuing the worker from suspended trauma. So we need to reduce the risk of venous pooling. We need to elevate the feet to alleviate the pressure, delay symptoms, and provide support for muscle pumping. So there's criteria here on this tip sheet that gives us information on how to deal with suspended trauma. Continuously monitor suspended worker for signs of symptomatic or orthostatic intolerance. Ensure that the worker receives standard trauma resuscitation once rescued. If the worker is unconscious, keep the worker's air passes open and obtain first aid. So first aid training is part of our process that we need to be trained in case we have a worker that is suspended from an elevated platform. And monitor the worker after the rescue to ensure the worker is evaluated by a healthcare professional in case they were engaged in that. But I would also come to say that this is the last line of defense. Fall protection is the last line of defense. The first line of defense would be appropriate training, appropriate machine selection, and appropriate workplace inspection, because if we do all these things, we're not going to be involved in a suspended trauma experience. So I want to put my focus back onto proper training, proper workplace inspection, and proper job site inspection. Inspection of the machine. But these are the 5 tip sheets that the SIA OSHA Alliance has produced to help manage your work site and promote the safe and effective use of these products in the market. That's all I have at this point, so we can open it up back to Katie for questions and answers.
Great job, Gary. We do have some great questions here, particularly with fall protection. So if we could address some of these first, I think that would be great. Okay. One question, I know you answered this, but maybe if there's any more that you can add to it, we'd love to hear it. One listener was saying that they were informed by an OSHA inspector that lanyards used on aerial lifts can't be retractable nor have a brake pad. The lanyard must be a restraint device. Is this being told during training classes, or is it in the operator manual? Well,
I think there's a lot of myths and misinformation that are out there, and they go all over the place. And to even find out where the information came from can be ambiguous. But So let me go back to the question. The question was about self-retracting lifelines.
I think they were talking about restraint devices. Sorry,
Well,
like a shortened lanyard.
I mean, if you go back to the actual regulation, 1926-502 G16 III, it states, the anchor point shall be rigged to limit 6-foot free fall or less, nor make contact with the lower level. And if you follow that regulation, it makes it very difficult to use a fall arrest system in an aerial work platform. And back to the presentation, when I tried to say fall restraint is the objective that you should go after. The shorter the lanyard, the more restrained you are in the machine.
Okay, great. What is the correct type of fall restraint lanyard to wear when operating an AWP?
You know, and I knew these questions would be all about fall protection. And the answer to that is it depends on the risk assessment of your job. You really need to look in the best practices document to determine what you're doing, how you're doing it, what you're doing it with, to determine the best fall protection system to put on in the type of AWP that you're using based on the application that has to be performed. And without trying to dodge the question, the more you talk about fall protection as it's associated with aerial work platforms, the further away the answer gets.
Okay, so can you maybe say what types must not be used?
You know, that's another way of asking, obviously, the same question. I'm being asked for a black and white answer, and if you go into the best practices, it does mention SRLs, it does mention short lanyards, it does mention adjustable lanyards, it does mention dual lanyards. And based on the task that you're performing, one may be a better solution based on the risk assessment of the job.
Okay. How about SRLs? Are they okay to use?
Well, I would say SRLs could be an option, and I'm only saying that from the statement of best practices because they are listed. But then you have to go back and say if it's approved by the SRL manufacturer, because some SRLs are only designed for the anchor point to be overhead, which makes them impossible to use in an aerial boom lift because the anchor point is not above your head. Okay. Then some SRL manufacturers will come along and say only if the anchor point meets the strength requirements, which then you'll have to have a comparison analysis of the machine that you're using. So I really have to go back and say based on the risk assessment.
Okay, great. Going back to some inspection points, is the use of electrical tape acceptable for repairing control cords, or does it have to be a manufacturer's repair?
I would say based as, I don't know that I can answer this question. I'm going to bring it from an opinion based. Some control conductors are low voltage. And on low voltage, i.e. DC voltage that controls the machine, in my opinion, electrical tape would be a sufficient repair because there's no electrical hazard. And now that conductor is now insulated by the electrical tape, so there's no hazard of it touching another conductor. Now, a energized AC-powered conductor, I would say that falls under a different requirement. Does that answer the question?
I think so. If it doesn't answer the question, please respond and let me know.
Now, because I've been asked this question by different people. Now, I've also seen and had where our OSHA compliance officers will go out and look at the control cable of the machine and not see a conductor inside the control cable, but see the insulators of multiple conductors because the control cable may have been damaged in some aspect. And they will say that electrical tape is not an appropriate repair. There's a part where, as a mechanic, I would disagree because it's not AC current. It's low voltage direct current and part of the control functions of the machine and doesn't fall under the electrical standard. So electrical tape would insulate the wires that don't have any conductors exposed. But it really kind of depends on the machine, the application, because as a mechanic, I've had to replace a conductor cable for the controls of the machine because someone didn't like that repair. So even though I said electric might be okay, it doesn't mean that someone else might allow that.
Right. Okay.
It's an interesting question.
Right. How would an annual inspection, and this may be going back to one of your inspection sheets, but how would an annual inspection be acceptable if there were defective welds?
Well, and what I was afraid that would be to come up. For the purpose of the virtual inspection, I would say that the annual inspection didn't apply to the 3 pictures that I showed. I don't want to suggest that an annual inspection occurred the day before I had a 100% severance in a control arm scissor tube. So for the lack of the virtual inspection, we'll say the annual inspection wasn't applicable to those machines.
Okay. Is it illegal for a worker in one aerial lift to work above workers in another aerial lift?
Well, it's certainly hazardous because now you have personnel working above you. I would say from a best practice perspective, you shouldn't work above other people.
Okay. How about some suggestions here? One listener said that they are often pressured by aerial work platform delivery personnel to not inspect or hurry the inspection of a machine. Do you have any suggestions for this person? How to get them to do
I want to rephrase the question. What I thought I heard you say is the operator was under pressure by the delivery entity not to inspect the machine?
Didn't say operator. Mark, could you say operator or, yes, he says correct. Correct, the operator often feels pressured.
Often feels pressured not to inspect the machine?
By delivery personnel to not inspect or to hurry the inspection of the machine.
Well, I think there's 2 different things that are happening here. When the machine is delivered, the delivering entity has a responsibility to provide familiarization upon delivery of that machine. And the inspection takes place after the delivery company leaves. So I'm going to say there's 2 different things in 2 different areas that are happening here. Because the inspection is the operator's responsibility, but can only inspect the machine once he's familiarized with it. So having the delivering entity walk the operator through the inspection, I can understand why the delivering entity doesn't want to get involved in that process because it's not their responsibility. The delivering entity only has a responsibility to provide familiarization upon rental, sale, or lease, or any form of beneficial use, not to inspect the machine. And I don't know that that's exactly answering the individual's question, but did it answer it anyway?
Let's see. Well, I'm going to assume yes, unless he comes back with some other question. Just a comment from going back to the electrical tape. The electrical tape does not have the waterproofing such as shrink wrap would. Thus, it's a possible short could have an could cause movement of the machine.
Well, I would say that would also maybe depend on the location and the area that was affected. Shrink tubing is obviously a better way of repairing different conductors, but I have to go back and say, what kind of conductor is it? Where's the conductor? What's the conductor operating? What's the severity of the damage? I mean, shrink tubing is obviously a better repair over and above electrical tape. But generally, I would say generally speaking, water, while is a conductor, it's not a conductor sufficient enough to bring in a contactor or a line contactor or a relay. Now, if you have a machine that has more intellectual properties on it, such as CAN bus communication, water more than likely will have the machine cease to operate. So I have to go back and say there's a lot of variables that I don't know how to come back and answer the question from a black and white perspective. Is electrical tape a satisfactory repair on a low voltage DC wire? I would say that depends. It depends on the wire, the location, what the wire operates.
Okay. This is the asker realizes this is a dangerous scenario, but is there any condition that exists where the lift operator should be tied off at an anchor point outside of the aerial platform?
Well, belting to an adjacent structure while working from an aerial platform is a violation of a federal regulation.
Okay, so there are no instances where the operator should be tied off outside. Okay.
I'm going to say belting off to an adjacent structure while working from an aerial work platform is a violation of a federal regulation.
Okay. Good deal. Let me put up the a couple things. Those are all the questions that we had. If there were any other questions that you'd like to ask, go ahead and post those now. If not, we can get those answered after the webinar. Gary has put up his email address earlier, and I can get that to you if you need me to. Mine is on the screen right now, so if you'd like to shoot an email, I'm happy to answer that or get you to the person that can answer your questions. I'm also going to put up the SAIA page that you can find the resources. It's at OSHA Alliance, saia.online.org/OSHA Alliance. It's under these aerial work platform resources. I can email those as well. Just shoot me your email address, and we can take care of it here. Actually, there were a couple more questions. Okay, this goes back to the operator, the delivery driver not inspecting the machines. The asker is saying that they understand the driver is not responsible for the inspection. The issue is inspecting before signing the contract from the driver and inspecting it before the driver leaves in case there are faults with equipment to save time for new delivery.
So I see him asking the question from two different perspectives. Is there damage to the machine that they may build for, and is the machine working properly before the driver leaves?
Right. And how do you get that to stop rushing it or do the proper inspection?
Well, I would say, I'm going to go back and answer the question from the dealer's responsibility. Has a responsibility to provide familiarization upon delivery. They don't have a responsibility to inspect the machine. Now, there's certainly damage is a problem within our industry. The machine was in pristine condition when I delivered it, and now it's in, let's just say, it's less pristine, condition. And so now we're going to have this go back and forth of, was it like that when you deliver it? Was this cover damage? Was this tire damage? And the answer that I would give you, if you're not getting the satisfaction from the dealer that you're getting the machine from, maybe you need to talk to the dealer and say, I'm not getting what I need from you, and if you can't get it, maybe you need to provide a different supplier of your equipment.
Right. Okay.
But I can't force a driver from another company to do what you're asking him to do. That's a relationship that this individual that's asking the question has with the dealer that's providing him the equipment.
Okay, go to the dealer. That's the answer. We have 3 questions, and you know what this question is.
It's about fall protection.
It's on fall protection, and it's on transferring or leaving the work platform. 3 questions. Maybe I'll run through real quick. Is it okay to exit a scissor lift for roof access? What situation would that be okay? Is it okay to leave the AWP to access a higher level? And is it permissible to transfer from an AWP to an adjacent work platform? All 3 of those questions have popped up.
Well, the way to answer that question is I'm going to start with the standards, and the standards say entering and leaving an elevated platform, if permitted by the manufacturer, follow their rules and instructions. Some manufacturers have publicized information, and some do not. So it depends on the manufacturer if you're following ANSI. Now that you're outside the platform, you fall under Subpart M, fall protection, and 100% tie-off must be achieved.
Okay, any follow-up questions to that answer?
Whew, that was all 3 questions at once, right?
I think so. I think we answered it. Safely accomplishing it, and when is it okay? Those are the those are the other portions to it. So, okay, it looks like the delivery driver is the driver not required to wait for inspection. I guess that's the crux of the question here.
Well, the answer to that is there's no standard that says the driver has to wait for the entity to show up. The dealer has a responsibility to provide familiarization to a person designated by the user. There's no there's no requirements for the driver to wait until someone shows up. The driver can drop the machine off. If the operator's been properly trained, it is plausible that he could read the operations manual, go over the control functions of safety devices, and familiarize himself with the machine. Or the operator could wait for someone from the delivering entity to familiarize him. But there's no requirement that says the driver has to wait till the individual shows up. What if he's not in a hurry to get there?
Right. Okay.
And I go back in my past years, and let me answer it differently. I remember doing a presentation for Mechanical Contractors Association that it was kind of along that same premise. How come your driver? How come And I came along and said, let's not worry about the times when the two don't meet. Let's worry about the times when they do. You're still not asking the questions. Let's bridge the gap on getting familiarization done properly when the operator and the truck driver are there at the same time.
Okay. Okay, one final question, and then it's 2:05, so we'll cut it off for today. But if you have additional questions, you can send them to me. I'll get them to Gary, or we can put Gary's email address back up on the screen. How do you know if the anchor point and lift can sustain an impact force from a fall? Anchor fail or lift tip?
You would have to see what the manufacturer has for design criteria of that anchorage point.
Okay, great. All right, folks. Thanks so much for your time today. Thank you, Gary. Thank you, Jim. Thank you, United Rentals, for sponsoring this event. Look for some more events coming in 2014. I know we've got some risk management, some insurance presentations coming up in January. Look for some information on that. And also some further AWP safety presentations in the future. If you have any questions, please don't hesitate to call us or email. I'm happy to take care of any questions or find the right person that you need to answer your questions. And with that said, you all have a great afternoon. We'll talk to you all soon. Thank you.